Okay, we're going to take a look at some arcs and chords. Let's first remind ourselves what a chord is, and our definition, we're going to put our definition up here. Definition of a chord is a segment with endpoints lying on the circle. So that's your definition of a chord. Well, we have a theorem that basically says if, or in the same circle, or congruent circles, so if I have the same circle or it's in congruent circles, if two minor arcs, remember minor arcs would be less than 180, are congruent, then, or if and only if, their corresponding chords are congruent. So let's draw a picture of kind of what that looks like. So if that's my circle, I'm going to call that circle L. Well, it just so happens that circle L has a chord that is FG, and it has a chord that is JH. So basically what we know is if FG is congruent to JH, then arc FG has to be congruent to arc JH. Or, because it's a double-sided arrow, we could flip that around, and we know that if arc FG is congruent to arc JH, then we know the chords have to be congruent. FG has to be congruent to JH. So if chords congruent, then minor arcs congruent, and so on. So that helps us if you are looking at in this packet with arcs and chords. So if we take a look at, say, something like number 3 on page 15. Number 3 on page 15, well, we know this arc, so this arc is congruent to this arc, so then we know the chords have to be congruent. And if that's the case, then we know 2x minus 12 has to equal 36. And so that's how you do that section, that 1 through 6 on page 15. Okay, another theorem that talks about arcs and chords tells us that if a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord or cuts it into 2 equal parts. So if we have a picture here and we have a diameter, we're going to call that diameter AB, and we have a chord right here, and our chord is going to be X, Y, and this is point Z. So if a diameter is perpendicular to the chord, if it's perpendicular to the chord, then it bisects the chord into 2 equal parts. So that is going that direction. If we think about the converse of that, basically it says if a segment would bisect the chord, or you have a perpendicular, we're going to say if you have a perpendicular bisector of the chord, so this is a little spin, it's not directly the converse, but if I have a perpendicular bisector of a chord, so let's draw our chord here, that's my chord, and I have a perpendicular bisector to it, so I know that this is congruent to this, and I know that it's perpendicular. Then I know that AB diameter. Put CV here if we want to. So this is the picture that goes with that particular one. So let's go back to the packet. So let's look at our picture. This is bottom page 15. We look at our little picture here. Well, if we've got a right angle, so we know that that is. Okay, we have one more one more property or theorem, and that it talks about if two chords are congruent, and that's in the same circle or two congruent circles. Two chords are congruent if and only if they're the same distance from the center. So if we were measuring distance from a chord from a center, well, we're going to walk a direct line. Well, when you're walking that direct line, you basically are going to have a right angle. So if I have this chord and this distance is, say, 3, and I have another chord, say right here, and that distance from there to there is 3. It's a bad drawing, but let's call this IJ. Then we would know that FG is congruent to, well, we can't say segment, we have to say arc. Arc, well, let's think about that. Let's start with segment. So segment FG is congruent to segment JI because we have these two distances are the same. So we know that the segments are the same. Well, let's think about that. If we know the segments are the same, then we know the arc is the same. So it all fits together. If it's equidistant from the center, now we can't call that a radius because it doesn't go to the outside of the circle. But if it's equidistant from the center, then we know the chords are the same. If the chords are the same, then we know the arc is the same. So if you look at the bottom of page 15, number 13, we have equidistant. They're equidistant from UL and UM are the same. So if we know that, then we know WV has to be congruent to YZ. If that's the case, then we know that 20 has to equal 5x. And so we know that x has to be 4. So that should set you up for the questions about chords and arcs on pages 15 and 16. You should be good to go.